So for today, we're still going to continue into our domain and range, but it's going to be with an equation. So we're not going to be given the picture of a graph or mapping or any of that. We are just given solely an equation. But we have calculators, so we can go and actually create a picture of that graph. So that's exactly what we're going to do. So for each equation that we're given, we are first, before we look at domain and range, going to look at the equation. So y equals 5x plus 2 is the first one I'm going to do. Y equals 5x plus 2. Oops, not equals 2, plus 2. So let me put this down. We can see we have a straight line. It's a linear graph. And if I zoom out and zoom out and zoom out and zoom out, like I can go, what is this, 100,000 or a million even? We can go so far and we can see that that line, it never, never, ever stops. So since it's never going to stop in this situation for a graph, it is going to just be all real numbers for our domain. I can go anywhere left and there's going to be a value for x in either direction. And same thing for y. There's no lowest point, no highest point. It goes forever and ever and ever. So linear equations are, in my opinion, the easiest because they are just always going to be all real numbers. I'm going to put actually S, so we don't have to write all the whole thing, but that means numbers. And same thing for the range, all real numbers. So here we have another equation, f of x equals negative 3x plus 4. To reset it, I'm going to hit the home, clear this equation, and I already forgot what it was. F of x equals negative 3x plus 4. F of x equals negative 3x plus 4. So here we have a negative slope for a line, but still linear. And same thing, I can zoom out and zoom out and zoom out, and it never, ever, ever changes. Like we're getting into exponential numbers here. We zoomed out so far. So it never stops. So again, the domain is all real numbers, and the range is all real numbers. Guys, on linear equations, that's what I should say here. In a linear equation, domain and range are always all real numbers. Our domain and range. If they give you just the equation, for instance, either one of these, it's always going to be all real numbers. But if we look at this, we notice we have an x squared and an x squared. These are not linear equations, so they are not all going to be all real numbers. So, though, let's go and graph it. F of x equals x squared plus 5. I'm going to close this, reset to the home. F of x equals x, and then to do the square, we hit the keypad and hit square, and it was plus 5. Plus 5. So you can click and move your graph. That's exactly what I'm going to do. And I want to highlight the graph, but zoom out. So notice it never stops going up, but it is one of those ones that curves, and this is called a quadratic. We're going to look at this next 6 weeks or the one after that. I can't remember. In the third 6 weeks. So when we are doing this, we know when it curves that our domain never stops. So the x value never stops getting more negative. It never stops getting more positive. So again, with an equation, I gave you a note here. The domain is always going to be all real numbers. Always. Anytime you're given an equation, domain is all real numbers every single time. The range, though, is what is going to be different for this when it is what's called the quadratic, where it curves like that. And for this one, we do note that the graph has a low point, so we can see that it starts here. If you click on this point, it'll be at the 5, 0, or 0, 5 rather. So that is going to be our first y value is 5. So our range is going to start 5, and then we're going to put y in the middle. And then if we notice, though, we have no maximum y. So for that, we are just going to simply delete the second inequality. And then remember, we need to write it correctly. We need to have it be y listed first. So the opening was to the y, so it's basically y is greater than 5. And we can look at that and see that all these numbers that were going up and up and up, they are greater than our 5. So our graph is going higher. So when we write the inequality, we have to say y is, oh, I gotta add that in here for you guys too. Special characters is greater than or equal to 5. So it's no longer this way. It's y is greater than or equal to 5. So any number that is bigger or equal to 5. For our last example here, we have y equals 2 minus x squared. So y equals 2 minus, oops, I'm not even typing. Y equals 2 minus x squared. So again, we see the graph way down here. So let's zoom out. And we notice that it continues. It's another curving one. So we know, again, since we have an equation, our domain is just going to be all real numbers. And then our range is what we need to figure out. So our range this time, we start from the bottom and move up, but we notice again there's no starting point at the bottom. So there's really nothing to put on the left side of this range. There's nothing to write, but we do have that highest point in this case. So in this situation, the highest point is going to be 2. So it stops at 2. It doesn't go any higher than that. So that's the right side. So in the middle, again, we're putting our y, but we have nothing to put to the left of it, so it just goes away. So then this is saying that y can be any number that is less than 2. And we can see that here. Here's our y at 2, but we also see the graph at -20, at -40, at -60. These are all numbers that are less than 2. So we know that our inequality is correct.